So let's discuss the perfectly inelastic collision. So what is perfectly inelastic collision? So the collision in which the total momentum remains conserved, but the kinetic energy does not remain conserved. Okay, so total momentum remains conserved, but total kinetic energy does not remain conserved. So let's suppose we have these two bodies. The mass of first body is m1, it's moving with velocity u1. Mass of second body is m2, moving with velocity u2. And when they collide, so after the collision, these two bodies stick together and move together. Okay, so there is combined velocity of these two bodies, that's suppose v after the collision. And what will be total mass? So it is m1 plus m2 is the total mass. Okay, so what can be an example of this kind of a collision? So for an example, you drop a lump of clay. Okay, a lump of clay, you just drop it on earth. Okay, a ball of clay, you can say. It doesn't rebound, it sticks with the earth, right? So it is an example of perfectly inelastic collision. All right, so you can throw a ball of clay on the wall, it sticks with the wall. So this is also an example of perfectly inelastic collision. Then suppose there is a car moving on road, and you take a ball of clay and throw it on that car. Okay, so that clay ball will move along with the car. So this can be another example of perfectly inelastic collision. Okay, so two bodies stick together and move together. So what happens? Momentum is conserved, but there is loss in kinetic energy. Okay, so where does that kinetic energy go? It gets converted to some other form of energy, right? So when these two bodies collide, there will be some heat generated. Okay, some sound will be produced, right? So it gets converted to these other forms of energy. So now we want to find out an expression for the final velocity and the final speed. Sorry, we want to find out the expression for final velocity of this perfectly inelastic collision, and also for the loss in kinetic energy. So we know that momentum is conserved. So using law of conservation of momentum, law of conservation of momentum, what can we say? That m1 u1 plus m2 u2 is equal to, so this is total initial momentum, it's equal to total final momentum. So what will be final momentum? So now these two objects, they stick together and move together. Okay, so the total mass is m1 plus m2, and suppose they move with velocity v. So it is m1 plus m2 multiplied by velocity v, right? And then you can take that m1 plus m2 on the other side, so you get v equals to m1 u1 plus m2 u2 divided by m1 plus m2. Okay, so we get this simple relation for the velocity in case of perfectly inelastic collision, right? So this is very simple. Then we can find out how much is the loss in kinetic energy. So kinetic energy lost will be equal to what? The final kinetic energy minus initial kinetic energy. Sorry, what will be kinetic energy lost? It is initial kinetic energy minus final kinetic energy, right? So it is half of m1 u1 square plus half of m2 u2 square minus final kinetic energy is half of m1 plus m2, this is the total mass, multiplied by v square. Okay, and then we can substitute the value of v. So what is value of v? It is m1 u1 plus m2 u2 divided by m1 plus m2. So we get half of m1 u1 square plus half of m2 u2 square minus half of m1 plus m2 multiplied by m1 u1 plus m2 u2 divided by m1 plus m2 and square of this thing. Okay, so then this m1 plus m2 and this thing will get cancelled out. Okay, so we have square of m1 plus m2 in the denominator. So here we'll have only what? m1 plus m2 remaining. Okay, so then we can write this as half of m1 u1 square plus half of m2 u2 square minus half of m1 u1 plus m2 u2 square of this divided by m1 plus m2. Okay, then we can make the denominator same. So we can multiply this term and this term with m1 plus m2 and divide by m1 plus m2. So what do we get? So kinetic energy lost will be equal to half factor we can take common. So it is m1 multiplied by m1 plus m2, that is, you can say it is m1 square plus what? m1 m2 plus m1 m2 multiplied by u1 square. Okay, then you have m2 square plus m1 m2 multiplied by u2 square. Okay, so plus m2 square plus m1 m2 multiplied by u2 square and minus square of this thing. So it is m1 u1 square plus m2 u2 square plus 2 times m1 u1 multiplied by m2 u2. Okay, so it is m1 u1 square plus m2 u2 square plus 2 times m1 m2 u1 u2. We have this thing, right? And then yeah, so we have to subtract out this thing. So what will happen? Okay, so this m1 square, sorry, we have m1 square, this is m1 square u1 square m2 square u2 square plus 2 times m1 m2 u1 u2. So this thing and this thing gets cancelled out. Okay, then this thing and this thing gets cancelled out. So we have m1 m2 u1 square plus m1 m2 u2 square plus 2 times minus 2 times m1 m2 multiplied by u1 u2. Okay, so if we multiply and expand, we get these terms. So this m1 square u1 square and this thing gets cancelled out. Then m2 square u2 square and m2 square u2 square minus m2 square u2 square gets cancelled out. So what are we left with? m1 m2 multiplied by u1 square plus m1 m2 multiplied by u2 square minus 2 times m1 m2 u1 u2. Okay, so what can we do is we can take m1 m2 common, right? And I forgot to write this m1 plus m2 in denominator. So in denominator we have m1 plus m2 also. So here it is equal to half of 2 times m1 plus m2. Okay, so 1 upon 2 times m1 plus m2, and I can take m1 m2 common from all these terms. So if I take m1 m2 common, I'm left with what? u1 square plus u2 square minus 2 u1 u2, and this is u1 minus u2 square, right? This is u1 minus u2 square. So what is the answer? Answer is delta Ke, or kinetic energy lost, is equal to half of m1 m2 divided by m1 plus m2 multiplied by u1 minus u2 square. So this much is the kinetic energy lost in case of and perfectly inelastic collision. Is it clear? It's a just calculation, okay? Just calculation, right? So yes, but we have to remember this formula as well as this formula. Okay. So there have been direct questions in NEET exam based upon this formula and also based upon this formula. Okay. So we have to memorize this. Okay. So then we will see an inelastic collision. Okay. So not a perfectly inelastic, partially inelastic collision. Inelastic collision. So again, in case of inelastic collision also, what we can say is the total momentum remains conserved, right? So the total momentum is conserved, and therefore you can say m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, right? And then we make use of coefficient of restitution. Okay, so now some kinetic energy will be lost. Some kinetic energy will be lost. It depends on how much is the coefficient of restitution, how much is the velocity of separation. Okay, so let's suppose the coefficient of restitution E is equal to, it is equal to what? We know that it is v2 minus v1 divided by u1 minus u2, and then you can take the u1 minus u2 on other side, so you get v2 minus v1 is equal to E times u1 minus u2, okay, or v2 is equal to v1 plus E times u1 minus u2, and we can substitute this in this equation to find out v1, okay, or we can find out v1 from here, okay, we can substitute that here to find out v2. So let's find out v1 and v2. So we have m1 u1 plus m2 u2, it's equal to m1 v1 plus m2 multiplied by v2, and for v2 what can we substitute? We can substitute this thing, right? So let's substitute that. It is v1 plus E multiplied by u1 minus u2, m2 times v1 plus E multiplied by u1 minus u2. Okay, so we have substituted for what? For v2. V2 is this thing, right? So let's multiply out and solve for v1. Okay, it is very simple. So this is equal to m1 v1 plus, from here, m2 v1, okay, it is m2 v1 plus E times m2 u1, okay, m2 u1 minus E times m2 u2, right? We can do this, and then we can shift this on left hand side, right? And I will rewrite this as, I will take v1 common, so m1 plus m2 multiplied by v1, so m1 plus m2 times v1 is equal to what? All right, so m1 plus m2 multiplied by v1, and then we are left with what? m1 u1 plus m2 u2 minus this thing plus this thing, okay, if we shift it towards left, right? So m1 u1 plus m2 u2 minus e m2 u1, and if we shift it on other side, this term will become positive. So e times m2 u2. Okay, then we can take u1 common. So if we take u1 common, we are left with what? m1 minus e times m2 multiplied by u1. Okay, plus if I take u2 common, it is m2 plus e times m2. So you can take m2 u2 common. Okay, so from here you will get 1, from here you will get e. So it is 1 plus e multiplied by m2 u2. Okay, and shift this m1 plus m2 on the other side, so you get v1 is equal to this thing divided by m1 plus m2 and this thing divided by m1 plus m2. Right, so we got this formula for v1, velocity of first body after the collision in case of an inelastic collision. I want to write down equation for v2, but I don't wish to solve like this. What should I do? Forgot? Yesterday I told just replace m1 with m2. Right, change m1 and m2. Okay, and u1 and u2. Right, so if you do that, you will get v2. So what will be v2? This m2 minus e m1 upon this is m1 plus m2 times u2. Okay, and plus, so since this is u2, I will shift it towards right, plus it is 1 plus e multiplied by m1 u1. Okay, 1 plus e multiplied by m1 u1 divided by m1 plus m2. All right, so this is formula for v2. Okay, and then there is one more formula, the loss in kinetic energy. Loss in kinetic energy in case of inelastic collision. In inelastic collision. Okay, so now you know what is the loss in kinetic energy in case of perfectly inelastic collision. It is half of m1 m2 divided by m1 plus m2 multiplied by what? u1 minus u2 square. Okay, so this is the formula for perfectly inelastic collision. So if collision is partially inelastic, okay, the collision is inelastic, just multiply this formula with 1 minus e square. So you get the formula for loss in kinetic energy in case of an inelastic collision. Got it? And this is very lengthy derivation. We don't need to solve. Okay, but this formula we need to memorize. What is there to memorize? Only this thing. So you just have to memorize the formula for loss in kinetic energy of perfectly inelastic collision and multiply that formula with 1 minus e square. Alright. Anyways, let's solve problems based upon this. So two spheres A and B of masses m1 and m2 respectively collide. A is at rest initially and B is moving with velocity v along x-axis. After collision, B has velocity v by 2 in direction perpendicular to original direction. The mass A moves after collision in the direction. Yes, there are two spheres. Okay, A and B. Their masses are something m1 and m2. Okay, they collide. So A is at rest. A is at rest. So which one is at rest? Whose mass is m1. The second one, it is moving with velocity v, initially along x-axis. So this is B. Its mass is m2. And then after the collision, what happens? B has velocity in direction perpendicular to original direction. So B moves perpendiculars to the original direction. So this is B moving perpendiculars to original direction with velocity v by 2. So this is B. Its mass is how much? m2. Okay. And the mass A moves after the collision in direction. In what direction it will move? Which thing is always true in case of a collision? Which is the thing that's always true? The law of conservation of momentum, right? So initial momentum was in x direction. How much was the initial momentum? It was m1 times v. Okay, in x direction. How much should be the final momentum? That one should be the final momentum also should be how much? m1 times v. So final momentum should also be m1 times v. Okay, in x direction. So this one, not m1, right? It is m2. This is m2. Okay, so initial momentum was m2 times v. Okay, it is momentum of this ball B, and final momentum should also be equal to what? m2 times v. Okay, so that means if this ball is moving like this, vertically upwards, okay, the other ball will have y component of velocity. Okay, y component of velocity. So let's suppose this is the other ball whose mass is m1. It will have y component of velocity like this. Okay, and x component of velocity like this. Okay, so it's what will be y component and x component? What will be y component and x component? Total initial momentum is m2 times v. Okay, what is total final momentum? So let's call it the total initial momentum m2 times v into I cap. Okay, so this body whose mass is m2, it's moving in y direction now. Okay, it's moving in y direction. So it is m2 times v by 2 is the speed. Okay, multiplied by what? Uh, it's moving in y direction. So let's call it j cap. Okay, so there is another body whose mass is m1. It will have two components of velocity. Let's call them vx and vy. So vx into I cap plus vy times j cap, right? So now if we compare the left hand side and right hand side, what do we get? We'll get two equations. Okay, so compare x component with this x component. What do you get? So m2 times v will be equal to what? m1 times vx. So from this you get vx is equal to how much? m2 upon m1 multiplied by m2 upon m1 multiplied by v. Okay, and then this thing plus m1 times vy into j cap should be equal to 0, because on left hand side there is no y component of velocity, there is no y component of momentum. Okay, so m2 v upon 2 plus m1 vy should be equal to 0. So how much is vy? Vy is equal to, move this on right hand side, so it is m2 v upon 2. Okay, and this m1 will go into the denominator, but when you move it towards right it will have negative sign. So minus of m2 upon m1, multiplied by v by 2. Okay, so see, what are y components of y and x components of velocity of this mass m1? So it is minus m2 by m1 v by 2 and m2 by m1 v. Okay, so the question is, the mass A moves after the collision in direction. So now if you find out tan of theta, let's suppose it moves in this direction, theta. So tan of theta will be equal to what? It will be equal to y component of momentum divided by x component of momentum. Okay, or y component of velocity divided by x component of velocity. So what do you get? So m2 upon m1 and m2 upon m1, it's common. It's minus v by 2 divided by v. Okay, or minus 1 by 2 upon 1. Right, minus v by 2 upon v, or minus 1 by 2 upon 1, or you can say it is minus 1 by 2. So theta is equal to tan inverse of minus 1 by 2. This is the answer. Okay, so answer is option D to the x-axis. Right, a mass m moving horizontally along x-axis with velocity v collides and sticks, okay, to a mass of 3m moving vertically upward along y-axis with the velocity 2v. The final velocity of combination is, so this is problem on the perfectly inelastic collision, because the two masses are colliding and sticking with each other. Okay, but this is simple problem. The first one is moving in x direction, second mass is it is moving in y direction. Okay, the final velocity of combination is, this is the question. So first one is moving in x direction with velocity v, so its momentum is mv times I cap. Second one is moving in y direction. Okay, the mass is 3m, right? Second mass is 3m and it is moving in y direction with velocity 2v. So momentum is mass times velocity, 3m multiplied by 2v times j cap. So then the final mass will be sum of these two, m1 plus m2, right? So m1 is m, m2 is 3m. It is 4m multiplied by some vx into I cap, you can say, plus vy into j cap, right? So m, m and m gets cancelled and you get vx and vy. So what will be vx? Vx is v by 4, right? And vy is how much? It is 3 times 2 divided by 4. So it is 6 by 4. Okay. So it is, answer is vx equals to 1 by 4 times v, and vy is equal to 6 by 4, that means 3 by 2 times v. So which option? Next one, a metal ball of 2 kg moving with a speed of 36 kilometers per hour, okay, has a head-on collision with a stationary ball of mass 3 kg. So 2 kg ball collides with 3 kg. Okay, after collision, both balls move as a single mass, then loss in kinetic energy due to the collision. Okay, very simple and straightforward. So first ball, its mass is m1 moving with velocity v, which is 36 kilometers per hour. That is 36 multiplied by 5 by 18 meters per second. How much? 10 meters per second. It collides with second ball, and after collision, these two move together, right? So what's our formula? So change in kinetic energy or loss in kinetic energy is half of m1 m2 divided by m1 plus m2 multiplied by u1 minus u2 square in case of perfectly inelastic collision. So how to get a gauge whether the collision is perfectly inelastic or not? If they stick with each other, it is perfectly inelastic, right? So this is perfectly inelastic. How much is U2? U2 is 0. Okay. So U2 is 0, U1 is 10, 10 square is 100. So this is half of M1 times M2. So 2 times 3 divided by 2 plus 3 multiplied by 100. How much? This 2 and 2 also gets cancelled. So 3 times 100, 300 divided by 5, 60. Next problem. A moving body of mass m and velocity 3 kilometers per hour. Is it the same one? No, this is different. So a moving body of mass m and velocity 3 kilometers per hour collides with a body at rest of mass 2m and sticks to it. Now the combined mass starts to move. What will be the combined velocity? Okay. So mass is m, first mass is m, velocity is 3 kilometers per hour. Okay. Plus second mass 2m, it's at rest. So this is total initial momentum. How much will be total final momentum? So m plus 2m is the total mass, that is 3m is the total mass multiplied by some velocity. So total initial momentum equals to total final momentum, right? So this is 0, this is 3m, okay, 3m equals to 3m times v, 3m and 3m gets cancelled, so v is equal to 1 kilometers per hour. This is the answer. Okay, next one. A body of mass, this thing, 5 into 10 raised to 3 kg, moving with speed of 2 meters per second, collides with a body of this much mass, 15 multiplied by 10 raised to 3 kg, collides with a body of this much mass and inelastically and sticks to it. Then the loss in kinetic energy of the system will be, again, straightforward. So what is delta Ke? It is half of m1 m2 divided by m1 plus m2 multiplied by u1 square minus u2 square. So second body is at rest. Okay, so it is u1 square only, right? u1 minus u2 square, second body is at rest, so u2 is 0, that means it is u1 square only. So half of m1 m2, so it is 5 multiplied by 10 raised to 3 multiplied by 15 multiplied by 10 raised to 3 divided by m1 plus m2, it is 20 multiplied by 10 raised to 3, okay, multiplied by 2 square, okay, so that one of the two gets cancelled out. 15 times 5 is 75, 75 multiplied by 10 raised to 6 divided by this 2 into 10 raised to 4, and that 2 gets cancelled out with, okay, another 2 from here, so it is 10 raised to 4, or you can say it is 75 multiplied by 10 raised to 2, right? If you take this 10 raised to 4 into numerator, it becomes 10 raised to minus 2, oh, sorry, minus 4. Okay, so 6 minus 4 is 2, 75 multiplied by 10 raised to 2, or 7.5 multiplied by 10 raised to 3 joules, that is 7.5 kilojoules. Okay, this is the answer, option A, right? One object of mass 20 kg is moving with speed of 10 meters per second in west direction. Another object of mass 10 kg is moving with 15 meters per second in north direction. Both collide and stick together. Okay, choose the correct alternative. So there is a big story in this, okay, but it is just to distract. See, this is just a straightforward conceptual question, and these numbers don't matter. Okay, in this question, their kinetic energy is conserved as it is inelastic collision. Okay, their kinetic energy is conserved as it is as it is elastic collision. Their momentum is conserved as it is inelastic collision. Their momentum is conserved as it is elastic collision. Which is the answer? Option C, right? Okay, so the collision is inelastic and momentum is always conserved. Right? Yes, no? Okay, so very simple question. Okay, then let's see this one. Two objects of mass m moving with speed u meters per second collide at 90 degree. Then final momentum is. Assume collision is inelastic. Tell me, what will you do? Collide at 90 degree. So this is first one, moving with speed u, okay, in x direction. Second one, moving with speed u with y direction, in y direction. Okay, so this is I, this is j cap. So how much is total momentum? Mu into I cap plus mu into j cap. This is total initial momentum. So this must be equal to total final momentum, right? So mu into I cap plus mu times j cap is equal to some, its mass will be m plus m because they are sticking together. So m plus m is 2m multiplied by some Vx into I cap plus some Vy times j cap. We have to find that Vx and Vy. So what will be Vx and Vy? So this m gets cancelled out, okay, and you can move 2 on left hand side. So you get Vx is equal to u by 2, Vy is also equal to u by 2, right? Okay, but question is, how much is the momentum? How much is total momentum? So it is, see, the momentum is 2 times. Okay, tell me how much is the total momentum? Oh, actually we don't need to solve this also. Total initial momentum equals to total final momentum. Yes, no? Okay, so tell me what's the answer? Should be square root of 2 mu. Okay, see, so total momentum is supposed to be the square root of momentum in x direction square plus momentum in y direction square. So that is square root of mu square plus mu square, right? So 2 times mu square, square root of that is root 2 mu. Option C. A body of mass 4 kg moving with velocity 12 meters per second collides with another body of mass 6 kg at rest. If two bodies stick together after collision, then loss of kinetic energy of the system is. Okay, very simple. So delta K is half of m1 m2 divided by m1 plus m2 multiplied by u1 square minus, sorry, not u1 square, u1 minus u2 square. Okay, where u2 is 0 because second body is at rest. So we just have to substitute values. If there is question like this or any question on perfectly inelastic collision, okay, that's a lottery. Okay, m1 times m2, so 4 times 6 upon 4 plus 6, 10, u1 square is 12 square, right? So this 4 divided by 2 is 2, 2 times 6 is 12, so it is 12 cube divided by 10. So how much is 12 cube? Yeah, option C is the answer. Okay. Man jumping onto a moving boat. Is this perfectly inelastic? Yes, because they will move together, no? A ball bearing striking another ball bearing. Straightforward. This is not perfectly inelastic. When they strike, okay, so one ball bearing will move ahead, right? So they will get separated. They will not stick together. So this is the answer. Okay. A moving body of mass m and velocity 3 kilometers per hour collides with a body at rest of mass 2 meters and sticks to it. Now the combined mass starts to move, then the combined velocity will be straightforward, right? So first mass is m, second mass is 2m. The velocity will be how much? Okay, m times 3, okay, plus 2m times 0. Velocity of second mass is 0 divided by m1 plus m2. So m plus 2m, right? So m times 3, 3m divided by 3, 1 kilometers per hour, right? So 1 kilometers per hour is the answer. Let us see next question. A ball falling freely from a height of 4.9 meters per second hits a horizontal surface. If E equals to 3 by 4, then the ball will hit the surface second time after. Okay, so this is a good question. Right, there is a ball which is released from a height of, okay, this is height of 4.9 meters per second. Oh, actually this is not meters per second, it should be meters, right? It falls from this height 4.9 meters. Okay, it's not meters per second. So it hits the ground with some velocity, then it will rebound, right? It will rebound with some velocity. So it rebounds, it goes to some height. So let's suppose it reaches this much height because its speed is getting decreased. Okay, so it reaches this much height. Now again it comes back. Okay, so this is first time when it hits the ground. Then again after some time it will hit the ground. So the time between this first collision and second collision, this is what we want to find out, right? So see, first of all we have to find out with how much velocity does it bounce. Okay, with how much velocity does it bounce. So height is 4.9, so the velocity with which it strikes is, let's suppose, v1. Velocity with which it bounces back is suppose v2. So how much will be v2 minus v2 divided by v1? Okay, E is equal to, I can say, v2 upon v1, right? So velocity of separation is v2. Separation from earth is v2. Velocity of approach towards earth is v1. So it is v2 divided by v1, and it is 3 by 4, right? So v2 divided by, how much is v1? Square root of 2gh. Okay, square root of 2gh. Then v2 is equal to, this is v2, the velocity with which it bounces for the first time is v2. So what do we get? v2 is equal to 3 by 4 multiplied by square root of 2 times g is 9.8 multiplied by h is 4.9. So 4.9 times 2 is also 9.8. So it is 9.8 square. So 3 by 4 times 9.8. This is v2. This is the velocity with which it bounces back. So again it will reach some height and stop. Okay, and again it will come back and it will fall on ground. So it will fall on ground with the same velocity as that of v2. So then it goes till this height in some time t. So what happens at that height is velocity becomes 0. Okay, so v becomes 0. So what can I say? V is equal to, okay, v is equal to v2 minus gt, right? Okay, so put this v equals to 0 over here. So we get g times t is equal to v2, and therefore t is equal to what? v2 divided by g. Okay, so which is 3 by 4. Sorry, so this is equal to what? 3 by 4, because v2 is equal to 3 by 4 times g. So this is equal to 3 by 4. Okay, but this is the time in which it goes till this height, right? It's the time in which it reaches this height. It will take same amount of time to come back also. So the time between these two collisions, right? These two bouncing. Okay, so then time between these two bouncing is equal to what? 2 times t. And how much is that? 3 by 4 times 2 will be 3 by 2. Okay, so 3 by 2 means 1.5 seconds is the answer. Then let's move on to the next problem. In two separate collisions, the coefficient of restitutions E1 and E2 are in the ratio of 3:1. In first collision, the relative velocity of approach is twice the relative velocity of separation. So in first collision, the relative velocity of approach is twice the relative velocity of separation. So let's call Vs is equal to velocity of separation, Va as velocity of approach. So it's given that Va is twice as that of Vs. So E1 is equal to what? This is 1 by 2. Okay. Then the ratio between the relative velocity of approach and relative velocity of separation in the second collision is, okay, so this is for first one, let's call them 1 1. Okay, and for second we want to find out ratio between velocity of approach and velocity of separation, right? So E1 is to E2 is equal to what? It's equal to 3:1. This is given. Okay, and E1 we found it's 1 by 2, so we can substitute that. So then we get 1 by 2 E2 is equal to 3:1. If we move this 2 on other side, we get 1 upon E2 equals to 6:1, right? And this is what we wanted to find out. So what is E2? It is velocity of separation in second event, Vs2 let's call it, divided by velocity of approach in second event, okay, Va2. Okay, and we want to find out the ratio of relative velocity of approach to separation, that is reciprocal of this. So what is reciprocal of this? It is 6:1. Okay, so option D is the answer, right? Let's see next question. A sphere of mass m moving with velocity u collides with another stationary sphere of same mass. Masses are same. If E is coefficient of restitution, the ratio of final velocities of first and second spheres is. Okay, so there is a mass m, it collides with another stationary mass. Okay, so initial momentum is m times u, final momentum will be m times v1 plus m times v2, right? So we can cancel out m here, right? Second body was at rest, so momentum of first body before collision plus momentum of second body is 0. So it is equal to m times v1 momentum of first body after collision plus momentum of second body after collision. Okay, m times v2. So m gets cancelled. So we get u equals to what? v1 plus v2. So let's call this equation 1. U equals to V1 plus V2. The second thing, coefficient of restitution. E is what? It is V2 minus V1, or let's call it, yeah, V2 minus V1 divided by U1 minus U2. Okay, and U2 is equal to 0. So this is equal to, this gives us what? U1 is U. Okay, so V2 minus V1 is equal to U times E. This is what we get. Then what can we do? So this is equation 2. So we want to find out ratio of final velocities of first and second spheres. Okay, so we can add these two equations. So if we add them, what do we get? V1 and V1 will get cancelled. 2 times V2. Okay, so we get 2 times V2 is equal to what? U plus UE. Okay, or 1 plus E times U. U plus UE. I have taken U common. So V2 is equal to 1 plus E times U divided by 2. This is V2. And what will be V1? So we can substitute this here. Okay, so what do we get? V1 is equal to, take this UE on left hand side, V2 minus UE. Okay, and if we substitute this, so this is 1 plus E, or let me write this as U plus UE divided by 2. U by 2 plus U times E upon 2 minus U times E. So what will be this? U times E upon 2 minus UE is half of U times E. Okay, and again you can take half common and also U common. So it is half of, if you take U common, it will be 1 minus E. So this is V1. Okay, so this is V2, this is V1. So if you take the ratio, what will be the ratio? So it will be U by 2 and U by 2 will get cancelled. 1 minus E divided by 1 plus E. This is the answer. Option B. This is the answer. Alright.